a claim variable, P, Q, R, S, A, B, C, D, whatever letter one might choose, represents a specific claim. The claim could be, the door is shut. The claim could be, I am hungry. It's a specific statement that presumably is either true or false. One combines these variables with various operators: the negation operator, the conjunction operator, the disjunction operator, and the conditional operator. What I'm going to do now is provide you with the definition, the truth functional definition of each of these operators. Let's start off with negation, the most straightforward. For some variable, P, we can place the tilde, the negation sign, before it, the result of which is as follows. P could either be true or P could be false. What the negation does is it's going to reverse that truth value. So if P is true, the negation makes it false. If P is false, the negation makes it true. So for instance, the statement I am hungry, when negated, it's negating the statement. It's saying it is false that I am hungry. Now, let's go on to the other operators. Let's start off with conjunction. We have P and Q. So, place that there. Let me put a P here. Let me put a Q here. And let me create a table for us. What one does when one creates a table is one wants to represent all possible permutations of truth values for the variables. So the way of doing this is with the rightmost variable listed, you alternate true, false, true, false. Then the next variable over to the left, you alternate true, false in units of 2. If there were 3 variables, the next row over, you'd alternate them in units of 4, and so on. As you can see, all possible permutations of true and false are here represented. True, 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 false, false, true, false, false. Now, the rule for the conjunction, the rule for the AND statement, that AND statement is basically saying that both P and Q are true. Hence, if both P and Q are true, 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 the entire statement is true. Since the statement is saying P and Q are true, well, what happens if one of them is false? Then the whole statement would be false. If I'm making the claim both P and Q is true, but Q turns out not to be true, well, obviously the statement both P and Q are true is false. Likewise, if P is false, and likewise, if both are false. Since the statement is saying P and Q are true, well, if neither is true, then the entire statement, P and Q are true, is clearly false. Now let's move on to disjunction. Now, what do we have? The disjunction is basically saying P or Q. That is, the statement P or Q would be true if either P is true, or Q is true, or if both is true. Now, the disjunction in logic operates slightly differently than how we use the OR statement in English. When I use the OR statement in English, I sometimes mean either or, in the sense that only one of the options is being allowed. I might say, for instance, we're either going to the movies or we're going to the park. And I might mean by that, we're not doing both. We're not going to do both. We're either going to do one or do the other. Sometimes, however, when I make that statement, both are options. If I say, would you like salt or pepper? And you said both, there's no problem. If I say, would you like salt or pepper? I'm not saying you can only have one of the two. So that is a statement with disjunction. A P or Q is saying that P or Q, that statement is true if either P is true, or if Q is true, or if both is true. And thus, if both P or Q are true, the statement is true. If P is Q is true and Q is false, the statement is true. If P is false and Q is true, the statement is still true. And then finally, if P is false and Q is false, the statement is false. So as we can see here, the statement P or Q is true in all cases except when both P is false and Q is false. Now let me move to the conditional. Okay. Now the conditional statement is definitely the most difficult one for people to grasp. The conditional statement, the if-then statement, the first part of the conditional, the if part, is called the antecedent. In this case, it's a P. And the second part, the then part, in this instance, the Q, is called consequent. So we have the antecedent and we have the consequent. Now the rule for the conditional statement is that the conditional statement is true in all cases except when the antecedent is true and the consequent is false. Let me explain it in the following way. Let's say we had a rule, we'll call it the McDonald's rule. And the McDonald's rule states that if Pasternak is hungry, he will go to McDonald's. That's the McDonald's rule. If Pasternak is hungry, he will go to McDonald's. What happens then if Pasternak isn't hungry? Well, he might go to McDonald's anyhow to meet a friend, or he might not go to McDonald's, he might stay home. If Pasternak isn't hungry and still goes to McDonald's, or if Pasternak isn't hungry and stays home, he's not violating the McDonald's rule. The McDonald's rule says specifically, if it is the case that Pasternak is hungry, then it is the case that he will go to McDonald's. If he's not hungry, doesn't matter what happens. You're not activating the antecedent. You're not possibly violating the McDonald's rule. The McDonald's rule is only violated when the antecedent is the case, that is, Pasternak is hungry, but he goes somewhere else other than McDonald's. The McDonald's rule is saying, if he's hungry, then he goes to McDonald's. So, let's say that's what happens. I'm hungry, I go to McDonald's, and thus the entire conditional is true. Now, if I'm hungry and I go to Burger King, well, then the claim, if Pasternak is hungry, then he goes to McDonald's, that claim would turn out to be false, because it's saying the McDonald's rule follows. McDonald's rule here is, if he's hungry, he goes to McDonald's. And if Q isn't the case, if I don't go to McDonald's, if I go to Burger King instead, then the entire rule, the McDonald's rule, the conditional is false. Now, if I'm not hungry, and I go to McDonald's anyhow to meet a friend, well, so what? I'm not violating the McDonald's rule. It doesn't say only if I'm hungry when I go to McDonald's. No, it's saying if I'm hungry, I go to McDonald's. There's no violation of the McDonald's rule. And in logic, you can only have a true or a false value for any claim and for any statement which includes claims and conditionals. So, the statement, if P then Q, I'm not violating it. I'm not violating the McDonald's rule if I go to McDonald's, but I'm not hungry. And so, since I'm not violating the rule, the statement as a whole remains true. Likewise, if I'm not hungry and I stay home, I'm not violating the McDonald's rule. And so there's no problem here with the conditional statement. The statement remains true. So what we can see here is, for the conditional statement, it's true unless it's the case that the antecedent is true and the consequent is false. That's the only time that the conditional statement becomes false. Otherwise, it's true. Take a look at these four tables. They appear in your textbook on page 301. You must understand these tables completely. You must have the memory. You must have an intuitive grasp of the logical structure that each of them represent. All the rest of this chapter depends upon that. You have to understand these in order to do translation. You have to understand these in order to do the long method. You have to understand these in order to do the short method. You really need to be completely confident with respect to these truth functional definitions, these tables. In subsequent videos, I'm going to go over the long and short methods.